Okay, we have now talked about the quadrilaterals that are a kite and the quadrilaterals that are trapezoid. We're going to continue to look at some different quadrilaterals, and the next type we're going to look at is what's called a parallelogram. Okay, so this starts out with the properties of a parallelogram. So you see the word parallel in parallelogram. Okay, what did it mean to be parallel? Okay, lines that were parallel never intersected. They did not touch. Okay, so we're looking at different properties of parallelograms. A parallelogram has two pairs of opposite sides that are parallel. So in this parallelogram, you see single arrows going on the left and the right side. That means that these two sides of the parallelogram are parallel to each other. And then you see a second set of arrows going this way. That means those two sides in the parallelogram are parallel to each other. So the opposite sides in a parallelogram are parallel to each other. That's one criteria that can be used to define a parallelogram, or what's true about them. Okay, it says parallelograms also have four other properties. So not only do we have opposite sides that are parallel to each other, but we have four other conditions that exist. And if we see those conditions in a quadrilateral, we know that we have a parallelogram. Okay, the first one is that opposite sides of the parallelogram are congruent to each other. So you see tick marks to show congruence. And remember, arrows are there to show parallel, but tick marks show congruence. So these opposite sides are congruent to each other. They're same length. Okay, these opposite sides are congruent to each other. They're the same length. So if we have opposite sides being congruent to each other, we know we have a parallelogram. Okay, that's one feature. Another feature of a parallelogram is it says opposite angles of a parallelogram are congruent. When we say opposite angles, so this corner, that's one angle, the opposite angle is in the opposite corner. Okay, this angle. Those angles are opposite of each other in the quadrilateral because they're congruent to each other. And then I have another set over here. This angle measure is congruent to the angle measure that's opposite of it. When I have two sets of opposite angles being congruent to each other, I know I have a parallelogram. Okay, a couple other things that we know. Consecutive angles. So opposite angles were opposite of each other in this direction. These angles are consecutive. These are next to each other. They come right after the other. So they can go consecutive in this direction. This is consecutive. As you go around the figure, the very next angle is consecutive. So these two, it says consecutive or adjacent angles of a parallelogram are supplementary. Okay, we've seen that word supplementary many times. It means they add up to 180. So angles going up and down like this that are next to each other, they add up to 180. Angles that are side by side like this, these are still adjacent to each other, these are going to add up to 180. Okay, these are consecutive to each other. These two are going to add up to 180, and these here are consecutive. They're going to add up to 180. Okay, and backwards, if you look opposite of each other, what do we know about those that are opposite? Well, they're congruent, and that's what the previous property said. Opposite angles are going to be congruent. Okay, these angles here, these are opposite of each other, and you notice they're congruent. That's what we said in the previous property. So consecutive angles, side-by-side angles, are supplementary. They add up to 180. Opposite angles are congruent in any parallelogram. Okay, and then the last property that we have of parallelograms, it says diagonals of a parallelogram bisect each other. So when I draw my diagonals in, okay, they are going to bisect, meaning this diagonal is cut in half. We have the same distance on both sides of the intersection point, and this diagonal is bisected. Both of them get bisected. Okay, remember, if you think back to the kite, when we drew the diagonals in for the kite, only one diagonal was bisected. In this case, for a parallelogram, both diagonals are bisected. So you're going to work on a worksheet in which you're going to decide whether or not you're looking at a parallelogram or not. And you are looking at a parallelogram if any one of these properties exist. So if in the diagram that you're looking at, if you see that both diagonals have been bisected, you know you have a parallelogram. If in the picture you have consecutive angles that are supplementary to each other, sorry, not congruent, supplementary to each other, then you know you have a parallelogram. If you have two sets of opposite angles being congruent to each other, you know you have a parallelogram. If both sets, I'm going to go backwards a little bit. If both sets of opposite sides are congruent to each other, you know you have a parallelogram. If two sets of opposite sides are parallel to each other, you know you have a parallelogram. So those are the different properties that we are looking for. Okay, so you're going to look at that worksheet and see if you can define which of those quadrilaterals on the page are actually parallelograms and which one are not.